Hello everyone, my name is Suzanna Smith and this is Unit 2's assignment titled Visualizing Hypothesis Testing. It is for the class Business Research Methodology and Quantitative Statistics taught by Dr. Nigel Basta. We have a long agenda that is going to be laid out for us during this slideshow presentation. The first topic I wanted to address involves what is statistics. Second, I want to go into some detail regarding common symbols that students will see in the statistics class. Definitions of null and alternative hypotheses will be addressed to help students to understand these concepts in detail. Another topic that is going to be addressed in this slideshow presentation is what are research questions? The other assignments that we're going to participate in during this slideshow presentation is testing for a mean, comparing two groups, efficiency comparisons, correlation tests, and then we're going to close this assignment with important takeaways. So what exactly is statistics? The word statistics has been said to have derived from the Latin word status. The discipline of statistics can be traced back to the 9th century. It is a mathematical discipline that focuses on data and hypotheses. Information, otherwise known as data, is observed as a form of scientific study. Data obtained is typically referred to as a sample. The goal of statistics is to analyze information gathered so it can be useful to individuals in future events. Statistics is concerned with exploring, summarizing, and making inferences about the state of complex systems. In actuality, there is no historical event to pinpoint when the art of statistics was actually born. The wise words of Confucius involve the phrase, "Study the past if you want to learn about the future." Many scholars argue that statistics is not a form of math, but is classified as metascience. In modern times, companies will often utilize data that is extracted from statistics to make important decisions. Before we get involved with dissecting the research questions, we should take a moment to discuss common symbols in statistics. There are several notations a person will need to become used to when you're looking at statistical formulas. Some of the basic vocabulary will involve relational symbols, corresponding population parameters, descriptions, Roman letters, and Greek letters, just to name a few. For this assignment, we will look at common symbols to include the null hypothesis, which will be depicted as a capital H with a subscript 0. The alternative hypothesis, which is a capital H with the subscript lowercase a. The equal symbol, the not equal symbol, or greater than symbol, or less than symbol, the greater than or equal to symbol, the less than or equal to symbol, the more than symbol, or the population mean symbol. All of these are commonly utilized within basic statistical information. For this assignment, let's analyze question 1, which is visualization testing for a mean. Before we analyze the research question, let's analyze the data we have been provided. There is the probability of defect and the number of defective widgets out of 100. Statistical questions are derived from identifying the claim. In this example, the test is performed on one mean so the researcher can better interpret the results. This translates to the attempt to make a claim about the population mean. In statistics, researchers can decide to perform a number of different tests to determine if there is a relationship to a phenomenon. One of the first tests they usually perform is a null hypothesis test. The null hypothesis states that there is no meaningful relationship between two measured phenomena. After the test is performed, a researcher can decide to reject the null hypothesis, meaning there is a definite consequential relationship between the two phenomena, or fail to reject the null hypothesis, meaning the test has not identified a consequential relationship between the two phenomena. The null hypothesis is considered the default in a scientific experiment. In contrast, an alternative hypothesis is one that claims that there is a meaningful relationship between the two phenomena. Looking at this graph, we have a bell-shaped slope with two tails on either side. If you really look at the information presented to you from the graph, it is a mirror image. This approaches and causes us to analyze this research question. On average, are the widgets from Acme Widget Company defect-free? The logical conclusion is that the null hypothesis is as follows. The mean number of defects is 0 per 100 widgets produced. The alternative hypothesis then is the mean number of defective widgets out of 100 produced does not equal 0. For visualization number 2, we are tasked with comparing two groups. The research question is as follows. Does the average major league team have more home run hitters than its corresponding minor league team? For this visualization test, we're tasked with comparing two groups. In the previous test, we analyzed situations where the data is not paired. This test requires us to compare two sets of data and examine the information. This circumstance is referred to as the two-sample situation. Arguably, it is one of the most common tests performed in statistical sampling. Each data must be independent from the other. For categorical data, the tester will compare proportions of characteristics of interest. The graph displays two bell curves, which are also referred to as normal distribution curves. Be advised, bell curves is often contemplated to be the line that is plotting using data points that meet a specific criterion. In this example, we are given two bell curves. The y-axis equals number of home runs. The x-axis equals fraction of the teams that are home run hitters. Minor league hitters is represented via the red bell curve. The major league home run hitter is represented by the blue bell curve. Based on a visual assessment, it is clear the major league hitters does have a minute increase in generating home runs when compared to minor league players. The research question is, does the average major league team have more home run hitters than its corresponding minor league team? Based on this research question and claim, the null hypothesis is as follows. The major league home run hitter equals that of the home run hitters for its corresponding minor league team. The alternative hypothesis is as follows. The average major league home run hitters hits more home runs when compared to its corresponding minor league team. For the exercise visualization number 3, efficiency comparison, the research question is as follows. The efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiencies? Conducting a proper efficiency comparison relies on several factors. First, there must be a proper sample utilized that have been drawn from a population that have measurable characteristics. Through the test, the researcher will acquire more of an understanding of scalability. In this visualization question, the claim is determining an efficiency comparison. Researchers are attempting to determine whether a queue with a single line of servers is more effective compared to a queue with 3 lines of servers. Be advised, the blue servers represent the single servers while the red represents the multi-servers. Visually, 2 symmetrical bell curves are utilized in the aid for analysis. The vertical axis represents the number of hours observed. The horizontal axis equals the number served per hour. In nearly all instances, the top of the bell curve represents the mean. By visual deductive reasoning, it is clear the red team demonstrated efficiency. The null hypothesis for this efficiency comparison is there is no mean different efficiencies between the red and blue groups. The alternative hypothesis is there is a mean different efficiency between the red and blue groups. Due to the bell curves presented, there is a difference between the means for each of the servers. There is no capability for the teams to have equal mean efficiencies. Therefore, the null hypothesis is rejected and the alternative hypothesis is supported. The final exercise within this PowerPoint presentation involves a correlation test. This visualization test is unique as the study failed to provide information related to their hypothesis test. This information would have been the basis behind establishing the claim. However, there are some aspects of the data that can be bold based on the scatter graph depicted in the scenario. According to the study, a German study tested how larger industrial use vans utilize gasoline. One of their analyses plotted miles per gallon versus the weight of the various vans in the study. After plotting the data on a scatter plot, the researchers performed a correlation test and found a significant correlation. However, they forgot to state their hypothesis test in their published paper. To help with the testing process, we do need to understand the information we have on hand. First, a scatter plot or graph was presented to us to help with analyzing different variables. The vertical axis equals the weight via poundage and the horizontal axis equals mile per gallon. A correlation is a type of analysis that is used to measure the strength and association between two variables. This analysis will then help clarify the relationship. One type of correlation is referred to as the Pearson-R correlation. It's a methodology utilized in a linear format to review related variables. The effective size of a standard is commonly weighed to evaluate the correlation between the coefficient between two data points. Based on the lack of hypothesis included in this question, we're left to make an assumption. By definition, a hypothesis is a statement of a prediction. When there's an absence of a hypothesis, the study becomes more broad. The important question is as follows. What were the study's null and alternative hypotheses? The null hypothesis is as follows. There is no correlation between miles per gallon and the weight of vans. The alternative hypothesis is as follows. The weight of vans and miles per gallon are correlated. Based on the information that we are provided, the logical conclusion is to reject the null hypothesis unless we are given more information to explore this study accordingly. In conclusion, let's talk about the different important takeaways of this PowerPoint presentation. A hypothesis should be clear so the researcher understands what they are trying to prove or disprove. Being overly ambiguous makes it difficult to understand the claim. A solid hypothesis will help the tester analyze significant data. A hypothesis should be testable and simple. Researchers can learn from the information and apply it in future studies. Gaining a firm grasp on the meaning of null and alternative hypotheses will benefit the researcher. Visual aids can help the researcher explain results. Words can become overly complex to the target audience. It is a tool that can be used to simplify data so it can be easily explained. People learn through different mechanisms, and visual tools is one of them. Ultimately, visuals can help with explaining instructions when testing a hypothesis. It is important to remember that statistics is not an exact science. There may be certain times when testers will achieve different results due to how they perform the tests. That is the beauty of statistics. Nothing is set in stone.